Look around you, look into the sky at night. Everything you see, the sun, the moon, distant galaxies, your body, your shoes, are all made of what we call ordinary atomic matter. The rest of the universe appears to be made of a mysterious, invisible substance called dark matter. Originally known as the missing mass, dark matter's existence was first inferred by Swiss-American astronomer Fritz Zwicky, who in 1933 discovered that the mass of all the stars in the COMA cluster of galaxies provided only about 1% of the mass needed to keep the galaxies from escaping the clusters. Astronomer Vera Rubin changed the way we think of the universe by showing that galaxies are mostly dark matter. The rotation curve was flat, meaning the stars in the outer spirals of the galaxy were orbiting at the same speed as stars near the center. More alarming, the stars in the outer spirals were orbiting so fast they should have flown apart. The mass of visible stars wasn't enough to hold the galaxy together. There was an extraordinary amount of matter missing. Bullet clusters are the best evidence to date for the existence of dark matter. The hot gas of the two colliding components, seen in X-rays, represents most of the baryonic ordinary matter in the cluster where the gases interact electromagnetically, causing the gases of both clusters to slow much more than the stars. The third component, the dark matter, was detected indirectly by the gravitational lensing. NASA's Chandra X-ray Observatory study of how dark matter in clusters of galaxies behaves when the clusters collide. A total of 72 large cluster collisions were studied by gravitational lensing. The axion is a hypothetical elementary particle postulated by the Peck-Equin theory in 1977 to resolve the strong CP problem in quantum chromodynamics QCD. If axions exist and have low mass within a specific range, they are of interest as a possible component of cold dark matter. WIMPs are weakly interacting massive particles, hypothetical particles which may be the main or only component of dark matter. Sterile neutrinos are neutral neutrinos that interact only via gravity and do not interact via any of the fundamental interactions of the standard model. In supergravity theories combining general relativity and supersymmetry, the Gravitinos the gauge fermion supersymmetric partner of the hypothesized graviton. It has been suggested as a candidate for dark matter. Self-interacting dark matter assumes dark matter has self-interactions in contrast to the collisionless dark matter assumed by the lambda CDM model. Dark matter is a form of matter thought to account for approximately 85% of the matter in the universe and about a quarter of its total mass energy density, or about 2.241 times 10 squared to the power of 7 kilogram per cubic meter. Experiments generally hunt for dark matter particles in two ways, either through a direct search in which dark matter particles bump into target material and scatter off atom nuclei. Understanding dark matter is important to understanding the size, shape and future of the universe. The amount of dark matter in the universe will determine if the universe is open, continues to expand, closed, expands to a point and then collapses, or flat, expands and then stops when it reaches equilibrium.